Still in the series of a collection of problems in calculus, question 11, let's continue. Which of the following is a one-to-one function in the interval from 0 to infinity? And we are given the options: sine x, 4x plus 7, x minus 1 times x minus 3, and all of the above. Alright. A one-to-one function is also called an injective function. There is a video on injective function you can do well to watch so you understand in detail what I'm going to be saying here. Alright, the interval we are giving is actually the set of positive numbers from 0, not inclusive, down to positive infinity. Now, what is an injective function, or what is a one-to-one function? So the definition of that injective function will help us to know which of them is one-to-one or not. We said that if we have two numbers, x1, x2, which are members of the domain A, for example, the function is injective in this interval if f of x1 is equal to f of x2. And by implication, x1 equals x2. That is the idea. So let us check. Let's start with the first one, or the first option, which is sine x. Sine x is not one-to-one. The reason is simply because it is a periodic function. Yes. For an injective function, one input value to one output. So no two different input value, no two different x, okay, will give me one output. That's what I'm saying. Sine x disobeys that condition. It violates that rule. It is periodic. The value of sine x will repeat itself at every 2 pi. Just listen carefully to this explanation. For a periodic function f of x, if it is equal to f of x plus t, where t is the period, the function is periodic. Sine x is periodic because sine x is actually equal to sine x plus 2 pi. At every 2 pi, the value of sine x will repeat. See, sine 30 degrees is actually 1 over 2, which is 0.5. Remember, we are working with positive numbers, so I'm dealing with sine 30, which is positive 30. If I add 2 pi in degrees, 360 degrees, to 30 degrees, that would be 390 degrees. Do you know that sine 390 degrees is also 1 over 2? I'm just taking an example. Yes. So you see that both outputs, they are the same. That means f of x1 is equal to f of x2. But the inputs are not the same. 30 degrees is not equal to 390 degrees. It means that the function is not injective. It is not one-to-one. Simple. So this option is wrong. Let me come to option C. This will be the last option. Of course, that's the answer anyways, but let's just see. Look at this function now, x minus 1, x minus 3. Is it injective? Is it one-to-one? No. The reason is simple. Just watch me. If I take a value of x, let's say x1, positive number, because we're dealing with a set of positive numbers. If I take x1 and plug 1 here, 1 minus 1 is 0. 1 minus 3 is minus 2. So I'm having 0 times minus 2, and that's 0. So what did I use? I use 1. Let me use another number, a positive number, let's say 3. If I plug in 3 here, 3 minus 1 is 2, 3 minus 3 is 0, and this will give me 0. The x1 and x2 I use, they are 1 and 3. F of x1 is 0, f of x2 is 0. You can see that to the same output, but two different inputs, it is not injective. So, of course, this will be wrong. All of the above, that's wrong because not all options are correct. This is the answer anyways. To do this, I'll use the formal definition of injective function to show that this function is injective. Watch me. F of x1 From here, I'll replace x with x1. Is that not so? F of x2, that will be 4x2 plus 7. So I am assuming that f of x1 is equal to what? F of x2 based on this. So I will be saying 4x1 plus 7 equals 4x2 plus 7. 7 cancels 7. Since they have the same sign, I'll be left with 4x1 equal to 4x2. Divide both sides by 4, x1 equals x2. And that is what is satisfied. So it means that the function is what? Injective. So this is the answer. Question 13. Let's solve. Let f be a function from arrow to arrow be defined by g of x equal to this function. This is a piecewise function. It is a function made up of two pieces. G of x is equal to 2x if x is less than 0. And it is equal to 2x plus 1 if x is greater than 0. And we have to find f of 2 minus f of minus 2, all divided by 3. It's a simple question anyways, just watch me. What is f of 2 in the first case? F of 2 is this. 2 is a number greater than 0. So to determine f of 2, I'll use this function. So this will be 2 into 2 plus 1, and that is 5. Okay. What is f of minus 2? Minus 2 is a number which is actually less or smaller than 0. To determine f of minus 2, I'll use this. And that will give me minus 4. Therefore, f of 2 minus f of minus 2 divided by 3 is equal to this. What's f of 2? F of 2 is 5 minus, what's f of minus 2? Minus 4 all over 3. And this is 9 over 3, which is equal to 3. That's it. So let's go to question 14. Alright, keep watching. Don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends and your classmates. Question 14. Let f be a function from x to y such that x and y are members of f. Y is called which of them? The dependent variable, the variable, the independent variable, the input variable. Of course, both x and y are variables. So this is not the answer. Now, a function is from x to y. X is called the domain. Y is the codomain or the range. The values in this domain, we use small letter x to represent them. Observe their difference. This x and y, they are the sets with capital letters. While the small x and y, they are the elements in each of the sets. You get me now? X is a member of this set and y is a member of this set. So we use small letter y to represent elements in the codomain. Domain is input value, this output value. So x, we call them the input values. So this cannot be the answer because we are looking for y. So y is either the output value or we call it the dependent variable. That is it. X is actually independent. So input values are always the independent variables, while the output values are always the dependent variable. That's just it for question 14. Now look at question 15. The function f of x equal to the square root of x minus 3 is undefined whenever, which of this option is correct? So the function will be undefined whenever that x minus 3 is less than 0. It will be defined if x is equal to 0 because the square root of 0 is 0. But the square root of, for example, minus 1 is undefined under the set of real numbers. You understand that? So x will be less than 0 plus 3, and that's 3. So the function will be undefined when x is less than 3. And that is option B. Question 16. If d of x is equal to 20 plus 1/2 into x squared, then this is d of x plus y, rather, not x and y. Then what is d of x plus y? They've given us a function already, which is d of x equal to this. That is 20 plus 1/2 into x squared. So what will be d of x plus y? D of x plus y will be, anywhere I see x, I'll just write x plus y squared. That will be 20 plus 1 over 2. Then here I'll be writing x plus y all squared. Before I proceed, looking at these options, no one is like this. So let me expand this x plus y squared. So d of x plus y is 20 plus 1/2 in brackets. If I expand this, it will be x squared plus 2xy plus y squared. So let me open that bracket. This will be 20 plus 1 over 2. Multiply everything here. So give me x squared over 2 plus s plus y squared over 2. If I use 1 over 2 to times this one, the 2 will cancel this, leaving us with just xy. Alright, so let me see if anyone matches this. I think I will have to simplify further. This will be 20, okay, plus, I can group this 1 over 2 x squared plus y squared plus xy. I think this should be the answer. xy, 20, 1 over 2 x squared plus y squared. Good. This is it. And that's the correct option, A. So it's quite easy. Question 17. If f is the function defined by f of x equal to this, 2x plus 1 when x is less than or equal to 0, x squared minus 2 when x is greater than 0, then the limit of f of x as x approaches 0 is what? We have 4 options: 1, 0, 2, or does not exist. Alright, this is the idea. The limit of this function will exist, alright, when the left-hand limit is equal to the right-hand limit. But if the left-hand limit and right-hand limit are not equal, then we say that it does not exist because there is a discontinuity at that particular point. When I say left-hand limit, I mean the limit of the function as x approaches 0 from the left. When I say right-hand limit, I mean the limit of the function as x approaches 0 from the right. That is 0 to the power of plus. You get the point? So if both of them are the same, that means it exists, and the common value is the answer. How do I determine the left-hand limit? As x approaches 0 from the left, means that we are talking about numbers less than 0. Because on the number line, this is 0. So this is to the left, and this is to the right. To the left, you have numbers that are less than 0, minus 1, minus 2, and so on. So I'm going to consider the interval that says x less than 0. In this interval, this is where I have x less than 0. So I will use this function to determine the limit of this f of x as x approaches 0 from the left. So anywhere I see x, I'll put 0. That will be 2 into 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. What about from the right? From the right, it means numbers bigger than 0. So I'm coming here now. This is where I have x greater than 0. So I'll plug in 0 here for x. That's 0 squared minus 2, and that's 0 minus 2, which is what? Minus 2. What do you observe? 1 is not equal to minus 2. They are not the same. It means that the limit of f of x as x approaches 0 from anywhere, that is from either the left or the right, does not exist. Because there is a discontinuity at x equal to 0. Both left and right hand limits are not equal, so it does not exist. Let k of x be equal to this. A similar question. Does the limit of k of x as s goes to 4 exist? First of all, what is the limit of k of x as s approaches 4 from the left? From the left, we have less than 4. You get it now? So I'm using this. So anyway I see x here, I'll just write 4. That will be 4. It's as simple as that. Then the limit of k of x as x approaches 4 from the right, what will it be? Plug in 4 here because we have greater than 4. So from the right means numbers bigger than 4. So I'm using this interval and I have x plus 4. So this will be 4 plus 4 and that's 8. They are not the same. So the limit does not equal 6. That is just the point. So because both left and right hand limits are not the same, it means that there is a discontinuity at the point x equal to 4 for this particular function. That is what it means. Question 19, let's go. If the function h of x equal to minus 1, given that x is less than or equal to minus 2, minus mx plus n, minus 2 if minus 2 is less than x and x is less than 3, and 3x if x is greater than or equal to 3, is defined on the real number line. That is the set of real numbers. We have to determine the values of m and n. Okay, let's see. To determine the values of m and n, let's ensure the continuity of this function at this endpoint, 3 and minus 2. Now, at x equal to minus 2, let's start with this. What is the left hand limit? Limit of h of x as x goes to minus 2 from the left will be equal to, we are dealing with left hand limit now. So where is x less than minus 2? Where is x less than minus 2? This is it. So this is the answer for the left hand limit as x approaches minus 2. The limit of the function as x goes to minus 2 from the right, what will it be equal to? For the right hand limit, it means that x is greater than minus 2. I can see it here. You know, if minus 2 is less than x, that means x is greater than minus 2. So I'll use this function to evaluate this. So anywhere I see x, I'll write minus 2. This will be minus m into minus 2 plus n. And what would that give me? 2m plus n. So for continuity of this function at x equal to minus 2, the left hand limit must be equal to the right hand limit. And that means that 2m plus n must be equal to what? Minus 1. Equation 1. Let's check the continuity of the function at x equal to 3. What is the limit now of h of x as x approaches 3 from the left? From the left, it is, we are going to make use of x less than 3. And I can see x less than 3 here. So I'll be using this. Anywhere I see x, I'll write 3. So that will be minus m into 3 plus n, which is minus 3m plus n. What is the limit of h of x as x approaches 3 from the right? That is where x is greater than 3. We use this function because this is where we have greater than 3. So I'll write 3 in place of x, that will be 3 into 3, and that is 9. So for continuity of the function at x equal to 3, I should have written that here, at x equal to 3. So for continuity at this point, these two will equate them. So minus 3m plus n equal to 9. This is equation 2. We now solve simultaneously. I can easily eliminate n. If I say equation 2 minus 1 or 1 minus 2. So let me say equation 2 minus equation 1 minus 3m minus 2m plus n minus n equal to 9 minus minus 1. This will give me minus 5m. This is 0. This will give me 10. And that means m is equal to minus 2. Alright, so m is minus 2. What is n? If I substitute minus 2 for m into any of the equations, this will be 2 into minus 2 plus n equal to minus 1. So minus 4 plus n equal to minus 1. N is equal to minus 1 plus 4. N equal to 3. So m is equal to 2 and n is equal to 3. Question 20. Determine the continuity or discontinuity of this function g of x equal to this at x equal to minus 2. So for continuity of the function, the limit of g of x as s goes to minus 2 from the left must be equal to the limit of g of x as x goes to minus 2 from the right. So if both of them are equal, that is, if this equation is satisfied, then the function is continuous at minus 2. But if they are not the same, then it is discontinuous. Let's check. The left-hand limit, okay, let me remove this equal to. The left-hand limit, we have to check for x less than minus 2 using this. So anyway, I see x here, I'm writing minus 2, right? So that will be minus 2 squared minus 1. And here, the right-hand limit, I'll be using this because this is where x is greater than 2, greater than minus 2. So I'll write minus 2 here, minus 2 plus 5. This will give me 4 minus 1. This will give me, minus 2 plus 5 is 3. This will give me 3. So 3 is equal to 3. So it means that the function is continuous at this point, x equal to minus 2. There's something I want to quickly say. There is the idea of left continuity and right continuity. The left-hand limit is equal to 3. The right-hand limit is equal to 3. If the left-hand limit, the limit of g of x, as s approaches minus 2 from the left, is equal to g of minus 2, that means the function is left continuous. If the limit of g of x as x approaches minus 2 from the right, which is the right-hand limit, is equal to g of minus 2 also, it means that the function is right continuous. We've gotten the left-hand limit as it approaches minus 2 as what? 3. What is the function's value at x equal to minus 2? If you look at this interval, x is both greater than minus 2, it is also equal to minus 2 at the same time. So I want to determine the function's value at minus 2. I'll be using this function. So f of g of minus 2 is simply plugging minus 2 here. Minus 2 plus 5. That will give me 3. So the left-hand limit is equal to the function's value at that point, minus 2. It means that it is left continuous. Of course, it is also the same thing with this. It is right continuous. Now let's answer question 21 and 22. All right. If a function f is defined by f of x equal to this, a minus 5x if x is less than 2, 3b plus ax if 2 is less than or equal to x less than 4, and x minus b if x is greater than or equal to 4. Determine the values of a and b if the limit of f of x as s goes to 2 and the limit of f of x as s approaches 4 exists. So since the limit of f of x as s approaches 2 exists and the limit of f of x as s goes to 4 exists, it means that the left-hand limit and right-hand limit for each of the two cases are equal. Now, at x equal to 2, the left-hand limit here is when x is less than 2. So this is where x is less than 2. I'll use this. So anyway, I see x here, I'll write 2. So this would be a minus 10. Then the right-hand limit, where s is greater than 2. This is where s is greater than 2. Because if 2 is less than x, it means s is greater than 2. So I'll write 2 here. This will be 2a plus 3b. 2a plus 3b or 3b plus 2a. Let me simplify this. Minus 10 will be equal to, if this a crosses, it turns to a minus. So we'll be having 2a minus a, which is a, plus 3b. Question 1. And let's come to the next condition. At the limit of the function as x approaches 4. So since it exists, it means that both left-hand limit and right-hand limit are equal. What will be the left-hand limit now? When x is less than 4, I'll be using this. So I'll put 4 here. 3b plus 4a, or 4a plus 3b. Then, for the right-hand limit, where x is greater than 4, I'll write 4 here. 4 minus b. Let's write this equation in this form. So this is 4a plus, if this minus b cross, it becomes positive. 3 plus 1, that's 4. 4b equal to 4. Divide both sides by 4. It means that a plus b equal to 1, which means that 1 is equal to a plus b. Question 2. I can easily solve this simultaneously. If I can eliminate a easily because they have the same coefficient. So let's say equation 1 minus 2. It means that minus 10 minus 1 is equal to a minus a plus 3b minus b. Minus 10 minus 1 is minus 11. This will cancel. 3b minus b is what? 2b. It means that b is equal to minus 11 over 2. So b is minus 11 over 2. So any option that does not carry minus 11 over 2 for b is wrong. This is wrong. This is wrong. I can see it here. But let me just verify that a is actually 13 over 2. So if I plug in minus 11 over 2 for a here, let's say in equation 2, 1 will be equal to a plus, what's b? Minus 11 over 2. So 1 plus 11 over 2 is equal to a, right? 2 times 1 is 2, plus 11 is 13 over 2 equal to a. So a is 13 over 2 and b is minus 11 over 2. This is it. Option A, correct option. So question 22, let's examine the continuity of the function defined by this. X minus 2 when x is less than 3, 1 when x is equal to 3, and 4 minus x when x is greater than 3. Okay, the options are here. Now, looking at this function, let's see. The endpoint we have 3, 3, the same. So we just have one endpoint, which is 3. Let's verify if the limit of f of x as s goes to 3 from the left is the same as the limit of f of x as s goes to 3 from the right. As s goes to 3 from the left, that is the left-hand limit, we have to make use of when x is less than 3, which is this. So I'll be using 3 minus 2, and that will give me 1. And for this, as x approaches 3 from the right, we use greater than 3. Remember that. So I'll be using this interval. So 4 minus 3, and that's 1. You observe that the left-hand limit is the same as the right-hand limit. That means the function is continuous at that point. Look at the options. Continuous at s equal to 3. Of course, since the left-hand limit is equal to the right-hand limit, it means that it is continuous from either side. Okay, so at s equal to 3, the function is continuous. That option is correct. Now, option B is wrong anyways. Option C says only continuous on the left at s equal to 3. Let's see. I told you, I think in question 20, this question 22, 21, in question 20, I said that a function is left continuous if the limit of f of x as s goes to that particular value. Okay, let me use 3 here from the left, if it is equal to the function's value at that point, f of 3. if they are the same, it means that it is left continuous. And if the limit of f of x as s goes to 3 from the right is equal to f of 3 as well, it means that the function is right continuous at s equal to 3. Now, we've gotten this one already before, the left hand limit, which is 1. What will be f of 3? F of 3 is also 1. So the function is equal to 1 when s equal to 3. So this is 1, this is 1. The right hand limit we got is 1. So the function is not just only left continuous. It is both left continuous, it is right continuous. Are you getting the point now? So it is not only continuous on the left. That's wrong. It is not also only continuous. Check. Only continuous on the left is different from continuous on the left. So it is not only continuous on the left, but it is both continuous on the left and on the right at x equal to 3. So in summary, the correct option is option A. Because it is both continuous on the left at x equal to 3 and continuous on the right at x equal to 3, then the function is just continuous at x equal to 3. So as x approaches 3 from any of the two sides, left or right, it is continuous.